Let's show some more examples of simplifying equations. So here's an original equation, y equals a and quantity a and b, or ABC. We notice that this term AB is the same as that term, and so we have covering. AB or AB and C is just equal to AB. So covering. And then we still bring down the other term, the A, and then we get equals A and B. Associativity, I can move those parentheses around across a term that's ANDed together. And then I have idempotency, A and A is just equal to A. And so then we get A and B. Here we have another example where we can use the covering theorem. And remember, A with a single quote is the same as A bar. That's just easier for typing. So when you write it, you want to write the bar in. It's very easy to lose those ticks or those single quotes. So this is equal to A bar BC or A bar. And we can see we have A bar or A bar and something. And we use the covering theorem to just, and if you want to keep that in the same spot, equals A bar using covering. So this expression here is in SOP form, and actually minimized SOP form. So that has the fewest number of implicants. Product terms has 3 implicants or 3 product terms, and each implicant has the fewest number of literals. We can't reduce them anymore. This term is not in SOP form because we have, well, we do have implicants here, but this is not an implicant. Right? Remember, an implicant is a product of literals. So the top one is in SOP form, and the bottom term is also in SOP form. This middle term, this middle expression or equation is not in SOP form. So here's an example of multiplying out to get, so we have this expression or this equation. It's actually in POS form. So product of sums and a product of these sum terms, these OR terms. And so the best way or the easiest way to do this is to recognize that strange form or dual form of distributivity where we have W or X and Z is the same as W or X, this term, and W or Z, the second term. And so we're actually going in this direction where we see this POS form of the equation and go to make it to these. This is actually an SOP form or sum of products form. And so we see the same term, A or something, quantity and A or another term. And so now we can, at our next step, say, well, that's equal to A or those 2 terms ANDed together. So we get A or, well, this term, C or D or E, ANDed with the next term, B. And so now we get equals A or BC. Right now I'm distributing this B across each of these terms. BC or BD or BE. Now we have our minimized SOP or sum of products form of the equation. We could actually multiply it out longhand, where we say, well, this is equal to A, or A and B, or C and A, or C and B. And so I'll show that once. It's a little bit painful, but we'll show it. So again, regularity will just go from the first term and distribute across the 2 terms. So A, or A and B, or C and A, or C and B, or D and A, or D and B, or E and A, or E and B. And so that first term is going to just become A using idempotency. And then we can see that A or actually covers all of these terms. A or A and B, or A and C, or A and D, or A and E. And so those terms all go away through covering. A or A and something reduces to just A. And then we can put down the other terms. So now we have our CB or DB or EB. And then we want to make sure that each of our implicants, our product terms, are in alphabetical order. So we say A or BC or BD or BE. And now you can see we end up with the same form. So we can't do it the brute force way, which is that way. But often, you know, a lot more terms to deal with and easier, right? The more terms we have, the more likelihood we have of making a mistake. So here's another expression, and I'm going to show an example of using the consensus theorem. And so one thing we can do for this, it's a little bit more tricky, and again, this is kind of one of the more rarely used theorems. But if we have this expression, we can see that we have some term, this B term, A and B, or B bar and something. So this B term we have, that's kind of the pattern we look for. A, B, or B bar D. And we don't have the consensus term here, right? The consensus term would have been or whatever they're ANDed with, ANDed together. So A and D bar. But it turns out that we can use that to help us. So if we add that in, right? It wasn't there, but we could add that in as an or A D bar. We know that that expression A B or B bar D bar is the same as AB or B bar D bar or AD bar. And then we can notice that, well, actually this term A or D bar covers that term. And so then we can reduce it. So that was step one. Step one was turning it into AB, try to highlight these terms, or BC or B bar D bar, or A C bar D bar. First step was to say, well, I can add in that consensus term and say, well, or AD bar doesn't change the logic. And so then we can say, well, guess what? That covers this more constrained term, AD bar equal, or AD bar C bar is equal to just AD bar. So we put that in here. And we still have our B bar, D bar, and you can see I'm keeping alignment here of my terms, or BC, and then we basically absorb that term. We absorb that term back in. So we take this term and we say, well, consensus says I don't need that. AB or BD bar or AD bar is the same as just AB or B bar D bar. And so then we get equals AB or BC or B bar D bar. Another way we could do that is we could say, well, and again, this is one of the more rare, you know, kind of methods that we'll use, but we could say, okay, well, we have these terms AB or BC or B bar D bar. Gosh, I mean, I can almost like absorb that into different terms, but not quite, right? Using covering, but I can use combining to get a B term into that. And so I can say, well, that last term is equal to AB C bar D bar or A B bar C bar D bar. And so we've taken this term here, we've basically added in a B term by using combining, or really reverse combining, right? We're uncombining that B out of that term. So A C bar D bar is the same as A B C bar D bar or A B bar C bar D bar. And now we can see that this AB term covers this half of that term. And then the B bar, D bar term covers this half. And so using covering, AB covers that term, so that term goes away, this entire term goes away. BD covers this term, so this term goes away. And we end up with AB or BC or B bar, D bar. Either way, method 1 or method 2, we end up with the same result. And here it is written nicely. So here we have another example of where we can use that dual form of distributivity. We notice A or something, some term, quantity and A or another term. That can just be A or BC and DE. I didn't have to put the parentheses there, but now I can use associativity to get rid of those parentheses. Again, we can use the brute force way of saying A, or A and DE, or BC and A, or BC and DE, and it will reduce to the same minimized SOP form of the equation. So I'm not going to show that. Or the brute force way, best to recognize that a pattern where we can apply T8 prime, the dual form of distributivity, but it will work either way. So now using the tools we have, we can show that in fact our SOP form of the equation, our canonical SOP form of the equation, where we have E equals C and M bar, this was from an earlier example in the slides, is in fact the same as our POS form, which they look totally different, but now we can show that they in fact are the same using Boolean algebra. So we can reduce this expression here and show that it's the same as the expression in SOP form. So probably the easiest way is to use combining one of the forms of combining, where we have C or M, quantity and C or M bar, these differ in a single term in the M term, and so that reduces to just C. And you can use that term again, C or M bar. These terms differ only in the C term, and so that reduces to just M bar. And so in fact we get the same result. So we can also take an SOP form of the equation, which is this form, is in sum of products form, and actually use our weird form of distributivity to put it into POS form. So we can say, well, W or XZ, which is the current form, is equal to W or X on the and W or Z, distributing that or across the and. So here we have A or B bar. That's equal to A or B bar, quantity and A or C, quantity and A or D, quantity and A or E. And the parentheses are important because and, so if we have A, B, or C, D, this and, right, has precedence, will happen before the or occurs. And so you can put those parentheses in, but you don't need to, because and has precedence or will take place first. Okay, And so we have to, right, if we didn't put these parentheses in, for example, let me get rid of these, this B and A would happen, B bar and A would happen first. So we need to keep those parentheses. Again, mostly you'll see expressions or equations in SOP or minimized SOP form.